Okay, good morning. I think it's time for us to get started. I'm Frieder Seible. I'm the Dean of the Jacob School of Engineering, and I want to welcome you to UC San Diego and to the Jacob School. What we want to do in this session is talk a little bit about the School of Engineering in general, and then we have two representatives from the Computer Science and Engineering Department and from the Electrical and Computer Engineering Department, give you some department-specific information. Then after those presentations, we'll dismiss you by department that you learn more specifics than about the actual department. So please stay until the end of all three presentations. Okay. So what I would like to do as Dean of the Jacob School, give you a general overview of what's going on in the Jacob School, but I want to start out with you guys. Okay, this is you. This year's engineering GPA is 4.1 to enter the Jacob School of Engineering, okay? And then the average SAT scores are 2013. That compares to a school-wide GPA average of 3.76 for UCSD and 1819 for the SAT scores. So you see it is much more difficult to get into the Jacob School of Engineering, okay? And so with that, okay, this is congratulations, okay? But you know yourself how good you are. As you can see, we had close to 10,000 applications for the Jacob School of Engineering, and in the end, we'll take less than 10% of you into the Jacob School, okay? So it's a very select group. Just one slide with numbers about the Jacob School, with close to 200 faculty in engineering. We have 10% of our faculty members of the National Academy of Engineering, which is a very high percentage for any engineering school. National Academy membership is the highest honor you can get in this country as an engineer. Since we do not have a Nobel Prize in engineering, it's being elected to the Academy of Engineering that is the pinnacle of your career. And to have 10% of our faculty at that level really speaks for the quality of our faculty. Also, with close to 6,000 students, we are the largest engineering school in California. But we are not just the largest, we are also one of the best, okay? When you look at the various rankings in the 46 short years since we are in existence as engineering here at UCSD, we have made it into the top 10 of research engineering schools worldwide, okay? And this is really an accomplishment, and as engineers we all can extrapolate out, you know, if in 40 years we have risen to the top 10, in another 10 years we're at -3 or so, you know. Clearly our bioengineering department is always the #1 ranked program in the country. The role of a research engineering school, and this is what we are, a research engineering school, is to do two things, namely to provide the human capital and to provide the intellectual capital. And the choice of words is very important. We're not talking about human resources and intellectual property. We're talking about human capital and intellectual capital. If we do not educate you, our students, such that you are marketable in the end, okay, that companies really want you, then we are doing the wrong job, okay? And so this is why we view you as our human capital, which we are producing. And if the research which we are doing as a research university is just being put on a shelf in the end and not makes it to the benefit of society, again, we are doing something wrong, okay? And so we have to transfer our technology to the benefit of society. And this is exactly what's reflected then in our mission for the Jacob School, namely that we are educating tomorrow's technology leaders. Just the fact that you have these high GPAs and these high scholastic scores means that you are not average engineers in the end, but we consider you technology leaders down the road, okay? That we conduct leading-edge research here at the university with the caliber of faculty we have, and we will talk more about research, and that we want you as undergraduate students to get involved in research already. There's a reason why you are coming to the Jacob School of Engineering, to one of the top research engineering schools, and then to transfer our discovery to the benefit of society. This is what engineers are supposed to do. A lot of our exciting research these days is happening on the interface between traditional disciplines And so, for example, just 3 years ago, we started the Institute for Engineering in Medicine, because 10 years ago, only my faculty in the bioengineering department were collaborating with faculty in the School of Medicine. And now in every single one of my 6 engineering departments, I have 3 or 4 faculty collaborating with faculty in the School of Medicine. Okay? This is where most of the exciting research is happening these days, on the interface between traditional disciplines. We also started just recently the world's first nano-engineering department, and as of this fall, we're giving degrees in nano-engineering. There's no other university in the world that gives degrees in nano-engineering, and this is again on the interface between chemical engineering, material science, electrical engineering, bioengineering. So our corporate partners came to us and said, we need a workforce that is trained in that nano scale, and so we developed then the nano engineering department. And then on the sustainability end, we do a lot of research on advanced energy technology, on photovoltaic research, new materials for photovoltaic, wind electricity generation, storage, energy storage, and so there's a lot of exciting work going on again on the interface between traditional disciplines. And this is really what the Jacob School is all about. We also have some of the most advanced and most exciting research facilities here on this campus, like in our California Institute for Telecommunication and Information Technology, some of the best visualization tools, virtual reality environments. On the structural engineering side, we have the Power Labs, which are the world's largest structural testing facility, and I will tell you a little bit in just a moment about that. And then we have our San Diego Supercomputer Center, one of the first National Science Foundation funded supercomputer centers. And let me just show you one quick thing what they're doing there. For example, they're simulating the big earthquake, which we expect here in California on one of our big teraflop computers. And you can see it here starting south of Palm Springs and then propagating northward. And then you can see how the shaking spreads. Here in San Diego, it doesn't shake anymore, as you can see, so we're in a good spot, but Los Angeles is still shaking, okay? It's that basin effect where the waves bounce back and forth. And then you can see Yuma, Mexicali. That's where we had the big earthquake a year ago at Easter time, okay? And so these are the kind of simulations which we're doing in our supercomputer center. Now in the structures lab, and I can tell you a little bit about it because that's my field, structural engineering, we have very unique facilities, like we have the world's only outdoor shake table where we can test structures of any size basically to send real earthquakes through and see how they respond to earthquakes. So this is a 7-story building, okay? We have a 2,000-ton payload on that table. That building was not even a quarter of that. So we can test structures 4 times as big, okay? And you can see then how every crack opens in the building during the earthquake, and this is how we then calibrate our analytical models. Many of you know this bridge here, certainly when you're from San Diego. This is our Coronado Bridge, one of our 9 toll bridges here in California. And Caltrans, after the 89 Loma Prieta earthquake and the 94 Northridge earthquake, went through a massive program to retrofit all of our bridges against earthquakes. And including the Coronado Bridge was retrofitted to the tune of over $100 million, okay? And the key part was to put the bridge on big rubber bearings. So on top of each pier are 4 of these big rubber bearings. And the whole idea is that during the earthquake, the pier shakes and the bridge doesn't even know that there's an earthquake, okay? So that's the whole idea. The other reason is that somewhere under the bridge is the Silver Strand Fault, which is an active fault where we expect, or our seismologists expect, a 3-foot horizontal offset during the earthquake. The only problem is they cannot tell you between which 2 piers, okay? And so we have to design the bridge such that between any 2 piers we can take a 3-foot horizontal offset and then have the bridge withstand the shaking, the deformations in these bearings. Now, bearings of that size had never been manufactured to date or tested to date anywhere in the world. And so we developed then here at UCSD in the Power Labs a testing system to test these bearings. So this is what would happen in the Coronado Bridge and the big earthquake. So it's just an example of some of the best research facilities we have here, and we find that in every single department, not just in structural engineering. The Power Labs are by now the world's largest structural testing facility. Okay. We have a lot of collaboration in our corporate affiliates program with many industry partners, as you can see here. Okay. And these companies are interested in us for the two reasons I mentioned, namely in our human capital and in the intellectual capital, which we generate here in the Jacobs School of Engineering. I met with the board members of our corporate affiliates program in small focus groups and asked them always the same question: what are the most important attributes you're looking for in our students? And the same two answers came back consistently. The top answer was teamwork, and the second answer was systems engineering. Okay? And so we listened to our corporate partners, and we started then 9 years ago a team internship program where we're not sending individual students for the summer to our corporate partners, but multidisciplinary teams of students to solve real-world engineering problems for our corporate partners. The first project 9 years ago was at a company called Abiomed in Boston, where they manufacture the artificial heart. And the CEO of Abiomed at the time told me that he wants 3 students for the summer in Boston: a student from electrical engineering, a student from mechanical engineering, and a student from bioengineering. And we're talking about undergraduate students here, okay, not graduate students. And these students were tasked to design and prototype the external battery pack for the artificial heart. And they did that in 10 weeks, okay, and that's what's being used right now. And it cost the company to fly the students out for the summer to Boston, to rent them an apartment for 10 weeks, to give them a rental car that they could do something on weekends, and to pay them prevailing hourly wages. And so it cost the company overall about $35,000, okay, to prototype, to design and prototype the external battery pack for the artificial heart. If that would have been a corporate internal R&D project, it would have been a multi-million-dollar project and a multi-year project, okay? This was the first success we had with our team internship program. So a couple of other quick examples.
I've had various internships over the past few years, and this has definitely been the most interesting. We worked on trying to get a system that can allow more renewables to be put on the grid. Yeah, we found the best approach is to use some sort of energy storage. I mean, a cloud goes over the city and all of a sudden your power drops. If we have a whole lot of solar panels spread across, then we need to have some way to, sort of buffer those differences. And so a battery system that can notice this, react to it, that was what we were in charge of designing.
I think the experience that the students get in the TIP program, in the projects they work on, at least at our company, they're very real-world projects. It's a very applicable experience. We have them solving some real problems that we're facing.
I liked it a lot because it prepared me for the real world, and I realized that this is what I want to do.
You see, in some of the teams, we also add students from other departments, like from the Rady School of Management to it, if it's a business component that the company is looking for. And at the end of the summer, all 4 students were listed on a patent as the G&E filed. Okay. Another example.
I mean, that's one great thing about this project, that we got to work with like cutting-edge technology. Not everyone gets to work with like a multi-touch table. Like even when I mention it to my friends, they're so amazed that I'm able to, play with a table like this. So, it's definitely out of this world.
The most exciting thing that I learned was how to interact with this touch environment.
The project that our team worked on was focused on something that we're in the process of commercializing already. And in fact, what they did was to help us commercialize it a little bit faster and a little bit better.
So the real research project was not just to play with that touch table, that oversized iPad, okay, but to have your cell phone placed on the touch table, transfer data wireless directly to the table, move it around, and then at the same time charge your cell phone, okay, while it's sitting on the table, okay, without having to plug it in. So this is what our students were working on. So this program has developed over the years. So for this coming summer, we are working on 64 teams right now in 35 companies, okay. These are the kind of opportunities which we're developing, hopefully for you guys, even more by the time you're ready for it. Another one of my declared goals is to take the Jacob School global, and that does not mean for us to start a satellite campus in Beijing, but for our students to get the opportunity to become global citizens. And what better way to do that than to work on an interesting engineering project in a multidisciplinary team with one of our corporate partners abroad for the summer, okay? And so you can see we are working on 7 international projects for the summer already, and every year this number of projects is growing. The feedback we get from our corporate partners on this team internship program is amazing, and it's very consistent. They say it is so much easier to have a team of interns than to have individual interns. When they have individual interns, it takes one of the corporate engineers to babysit the intern for the summer. When you have a team of students, they answer 90% of the questions they have amongst themselves. And then they always drive each other to solve the given project ahead of schedule and below budget. And then the students come back, since they come from different departments, and they tell me that they learn so much from each other. The best comment I got was, we learned so much more than we ever learned in the Jacob School. And that's just fine for me to hear, okay? During the academic year, we have a very similar program where we send multidisciplinary engineering teams, this time not to our corporate partners, but to non-profit organizations to solve real-world engineering projects for our non-profit organizations. For this, you don't get paid, but you get academic credit for it. So you can use this as a technical elective toward your degree. And just recently, we extended the TIES Teams in Engineering Service program to global TIES, again in the same spirit to take the Jacob School global. And we have now international projects, like a project in the Philippines and a project in Kenya, okay? And so there again, we are sending our students abroad to work on real-world engineering projects in multidisciplinary teams. Currently, the Jacob School has 6 academic departments: bioengineering, computer science and engineering, electrical and computer engineering, mechanical and aerospace engineering, nanoengineering and chemical engineering, and structural engineering. And you can see here the various buildings where these departments are housed. All very modern facilities, state-of-the-art research laboratories like you will not find at any other university. Our main building, Jacobs Hall, is where our student services are housed. Also the dean's office is there. So on the ground floor, we have the IDEA Student Center, our Center for Inclusion, Diversity, Excellence, and Advancement. This is the center that really is there to help you as student to be successful. We want not just for you to come to the Jacob School, we also want you to graduate from the Jacob School, okay, and not drop out beforehand, okay? And so this is the center that will help you accomplish that. We have our Gordon Center for Engineering Leadership there. We have our Von Liebig Center for Entrepreneurism and Technology Advancement. We also want to instill in you a little bit drive to be entrepreneurial when you're here in the Jacob School of Engineering. And then we have our Qualcomm Conference Center there. So this is one slide about our IDEA Student Center for Inclusion, Diversity, Excellence, and Advancement. And we have great staff here, and they have an open house today from 10 to 2. So if you have any specific questions after this session, you're welcome to go over to Jacobs Hall and talk directly to a representative from our IDEA Center. I want to take 2 questions right now, which I get constantly after every single one of these sessions, and I try to answer them, hopefully for you, okay? The one question is, I've been assigned to a certain college here at UCSD, but now I hear that Warren College is the closest to the Jacob School of Engineering, and I want to be in Warren College, or do I have to be in Warren College to be an engineer, okay? The answer is no. You can be in any one of our 6 colleges and be in engineering, okay? The colleges are the social arrangements. They are responsible for your general education requirement, but you get your degree in engineering in your various departments, okay? And you can be in any one of the 6 colleges and get your engineering degree. Actually, I like the college system we have is because it does not allow us as engineers to dictate your general education requirements. They're dictated by your college. And this is very important. We do not want to turn you into complete engineering nerds, okay? This additional general education is extremely important, especially in the global market these days. Students in Asia get the same technical education these days, okay? But as a culture, they are not getting the same general education. They are not getting the same education in entrepreneurism. They are not getting the same education in taking risk, okay, in learning from failure. These are all the kinds of things that set our students still apart, and this is why I still prefer any one of our students at any day over some of the students which we get from other countries, okay? And this is part of our college system, and I want you to see that as a real benefit. The second question I briefly want to answer is, another question I get is, can I transfer from one engineering major to another or from one major at UCSD into another? And the answer is yes. Once you're here at UCSD, you can transfer into any other major, provided that major is not declared impacted, okay? And we have a few impacted majors here at UCSD because we have too many students enrolled in those majors. And in engineering, we have 4 impacted majors. This is bioengineering, biotechnology, mechanical engineering, and aerospace engineering. And so those are the 4 majors you cannot easily transfer into. But any other major at UCSD, even in engineering, you can transfer into, okay? You have been admitted to UCSD, you can transfer into any of the non-impacted majors. We have a very thriving student community here with 29 pre-professional student organizations, and I encourage you to get involved in these pre-professional student organizations. This is part of leadership training, part of being a technology leader in the end, that you also get involved in your professional society, okay? And I can only encourage you to take advantage of these opportunities. One of the programs our Triton Engineering Student Council and our student orgs put together every year is DCAF, the Disciplines in Engineering Career Fair, and it's strictly organized by our students, okay? So earlier this year, they got 75 companies to come on campus here in this room, okay? 2,500 students participated in that career fair, and you can see that our students are entrepreneurial. They are charging these companies for coming, okay? So they raised $75,000, okay, from these companies, and that's exactly the kind of entrepreneurial spirit we want to instill in our students. And then finally, we also want to make sure that you learn a lot here, but also have some fun value here. We want these next 4 years to be the best 4 years of your life, okay? And so here's a quick video on undergraduate student life. Okay.
So one of the best things about the Jacobs School is the other people. We do all sorts of design projects with like robotics, we have BattleBot competitions, we have submarines, and it's just a real blast to be able to use what I learned in school hands-on to make something for a great project.
So I'm on a team that actually launches a balloon satellite. It's a high-altitude weather balloon that reaches near space, and underneath it we have a parachute and a payload system. Each payload holds a certain experiment.
It's just a beautiful campus. I like working for Dr. Engler because his door is always open, in that whenever we have questions, we can just go in and ask him. So we get a lot of one-on-one training with him. And because of that, I feel like I've learned a lot from this experience in terms of how to think like a researcher.
I'm on a team of undergraduate students who are working closely with NASA's computer scientists to redesign their entire search site for the images returned from Mars, so that the scientists can use these images to further their knowledge of Mars, and also for the general public so that they can see these awesome pictures.
When I was a freshman, I got to meet a lot of people. I got to like decide which org I want to join, and then I got to go to a club and then meet a lot of people. So it's a really good experience. It really helped me to break my shell.
I like the ties to industry. One of the things that really caught my eye was the team internship program, which I did freshman year, and it was a great experience. And then the other thing was when I think it was freshman admit day, and IEEE was out there with this table, and they had NATCAR. And here was this huge jumble of wires and electronics that some guy had built, and I said, well, that's what I want to do.
I like the community. I'm really involved in organizations. and I really like being a part of that.
So one of the wilder projects I got to work on within the structural engineering department actually was investigating how whales hear, specifically trying to determine the acoustic pathways of beaked whales with Professor Crissell.
My graduate student, Dan Kagan, he said, well, day, yada, yada, yada. And I was like, wait, what? He goes, oh, I put your name on the paper. I'm like, oh, that's cool. And inside, I was just like, oh, yes, this is my first paper and everything, so.
So you can see these are not graduate students we're talking about. These are undergraduate students getting involved in research. And this is exactly what I want you to take away from this session. You are joining, hopefully, a research engineering school, so take advantage of the fact, participate in research from the beginning. That's the good news. The bad news is for your parents that don't even think that your kids are done in 4 years with schooling, okay, because they will all go on for graduate degrees, okay. So with that, I hope that I'll see all of you this fall here in the Jacob School of Engineering. So thank you very much.